Let's try to do the same thing with the equations x equals 6 cosine theta, y equals 2 sine theta. In order to get y as a function of x, or at least y in terms of x, what we get might not be a function, remember. We solve the x equation for theta and plug that in to the y equation. So we do that easily enough. At least we start out easily enough. We eliminate theta, and we solve the first equation for theta. We get cosine theta equals x over 6, dividing both sides here by 6. And so theta is going to be the inverse cosine of x over 6. And then we plug that in here, and we see that y equals 2 sine theta, which is then 2 times the sine of this expression for theta, inverse cosine of x over 6. Now how do we simplify this? I've claimed down here that y then equals this, but how do we get from 2 sine of inverse cosine of x over 6 to 2 times the square root of 6 squared minus x squared over 6? Well, we have to think about what the inverse cosine means. What is the inverse cosine of x over 6? That is the angle whose cosine is x over 6. So this inverse cosine of x over 6 is an angle. We're taking the sine of that angle. If we could draw a picture of a triangle that has this angle in it, then maybe we could determine what the sides of that triangle are, and then the sine would just be the opposite side over the hypotenuse. Well, let's see what we can do. Okay, in the first place, the cosine of the inverse cosine of x over 6 is x over 6. That means that we can draw a triangle, and the inverse cosine of x over 6 is the angle whose cosine is x over 6. Okay, so here's the angle. If the cosine is x over 6, that means that the adjacent side over the hypotenuse is x over 6. Well, if we let the adjacent side equal x and the hypotenuse equal 6, then the cosine of this angle certainly is x over 6. So, by making a triangle whose adjacent side is x and whose hypotenuse is 6, we get the angle inverse cosine of x over 6, right here. So there's our triangle. If we want the sine of the inverse cosine of x over 6, what do we have to do? Well, we have to take the opposite side over the hypotenuse. Do we know the opposite side? Not yet, but we're going to very quickly. If we know two sides of a right triangle, we can easily find the third using the Pythagorean Theorem. Since the square of this plus the square of this equals this, the square of this is going to be the square of this minus the square of this, so this is going to be the square root of the square of the hypotenuse minus the square of the adjacent side. Straightforward idea, straightforward calculation. So we see that we have this angle, or I mean this opposite side. The angle inverse cosine of x over 6 then has a sine that's equal to this over this. So we say the sine of the inverse cosine of x over 6 is the square root of 6 squared minus x squared over 6. So that's where we got this expression. So now we see that y is 2 times the sine of the inverse cosine of x over 6, which is going to be 2 times this expression. From this, we see that y squared is 4 times 36 minus x squared over 36. In other words, squaring both sides. And we simply do the simplification. I'm sorry, I was thinking about something having to do with that square root. We're not going to talk about that. I was debating. Okay. Don't want to confuse you with too much information. Okay, now 4 times, well, again, we square this, and we obviously get this. Multiply through by the 4, and then divide through by the 36, and we get this. So y squared is 4 minus x squared over 9. Multiplying by the common denominator, we have 9y squared equals 36 minus x squared. That's the equation of a parabola, of an ellipse, with the two squares here. We could put that into standard form, bring the x squared over here, and then divide both sides by 36. And we could then obtain the standard form, and here are the details. Again, we bring the x squared over here, we divide by 36, we get 1 here, get the denominators here, and this is going to be x squared over 6 squared plus y squared over 2 squared equals 1. Let's go back to the original equation. We've got x equals 6 cosine theta, y equals 2 sine theta. Obviously, from the way we looked at ellipses before and the parametric equations for an ellipse, this is an ellipse with a semi-major axis of 6 and a semi-minor axis of 2. And of course that's exactly what we get down here.